Hello, everyone. Welcome. Thank you for taking the time out of your day to join us for today's presentation. We have Jeb here from the Low E team. And while I let everyone trickle in, I want to quickly show you all where you can learn a little bit more about Low E on Acelab. All right, so my page is coming up here. So you should be able to see my screen here. I have Low E's page pulled up. So anytime you're looking for a specific manufacturer on Acelab, all you have to do is search at the search bar at the top of their page, and this will pull up their page. So you'll see here we've got some basic information. We've got Jeb's contact information here if you'd like to get in touch with him. We've got a few highlights as well as many of their products for you to explore. So if after today's presentation you're interested in any specific item, you can click into these here, learn a little bit more about them, and then you can also save them to your firm library for future reference. So definitely when you have the time, check this out. There's a lot of great information here. I will drop a link to their page in the chat so you can use that for reference. A couple other housekeeping items before we get started. We will be doing Q&A towards the end of the presentation. So if at any point you have a question, feel free to drop that in the chat or in the Q&A box at the bottom. And then at the end, we'll read those out loud and answer as many as we can. We will also be doing a poll during the webinar. So you'll see that pop up on your screen. If you'd like to get more information from Jeb and his team after today's webinar, you can fill that out and we'll get in touch with you. And we will also do a post-webinar survey to collect any feedback that you have. So that is all that I have from my end. So I'm going to go ahead and pass it over to Jeb to get us started.
Thank you, Kayla. Hello, everybody. As she said, my name is Jeb Beard. I'm the Director of Business Development here at Environmentally Safe Products. So the name of our company is actually Environmentally Safe Products Incorporated, but nobody knows us that way. They actually know us by the name of our product line, which is Low E Insulation. So if you ever hear Environmentally Safe Products or ESP, that is us. But most of the time, people will just refer to us as Low E Insulation. So just have a PowerPoint presentation here to share. And then we'll get started. There we go. Kayla, look good?
Yep, looks good.
Okay. All right. So as I said, name of the company, Environmentally Safe Products. The name of our product line is the Low E Reflective Insulation line of products. We've been in business for about 35 years. We have two manufacturing facilities, one in New Oxford, PA, the bustling metropolis. Everybody's heard of that, right? We're about 10 minutes from Gettysburg, PA. Everybody knows where that is. And then we have a second facility in Carson City, Nevada, that kind of handles the West Coast. So we ship all over the country, and even overseas. We have wholesalers in Europe and Norway. We sell product into Africa and Kabul and all kinds of places. So we're available all over the world. Again, we've been in business 35 years. And if you look us up online, we have no complaints, which is pretty difficult to say for a company that's been in business for that long. We manufacture, like I said, the Low E line of reflective insulation. All the way back at the start of the company, we had one product. And every single product that we have come up with since, which is now about 35 to 40, has come from somebody in the field saying, hey, can it do this? Can it do that? Why can't it do this? Why can't it do that? And we go to work on trying to figure out how to make it do that. The two products that we are here to talk mainly about today are Low E Thermo-Sheath and our Low E House Wrap. First of all of our products are 100% made in America. All of the products are sourced here in the country, down to our bags and the zip ties that we tie those with. Now, to learn about our products, we have to talk a little bit about the science. I know that's an incredibly exciting thing to talk about, so I try to keep it a little bouncy and fun. Anyway, there are three types of heat transfer out there. The first is conduction. That's the first one everybody learns about when they're a kid. Don't touch the stove. The stove is hot. The second is convection. Everybody out there, I'm sure, has heard heat rises, right? When you're driving down the highway on a hot summer day and you see those wavy lines above the concrete, that is heat attaching itself to moisture and rising. Heat does rise, but that's not the whole story, and we'll come back to that later. The third, and the most important to our means here today, is radiant heat. Radiant heat is basically heat from the sun or some kind of man made source. But again, for today's presentation, we're mostly talking about heat from the sun. Now, in this industry, it is driven by R value. Everybody wants to know what's the R value. Hey, how much is the R value? What's the R value? But does anybody even really know what that means? Does anybody really know the definition of R value? It is resistance to conductive heat flow. That word conductive is important here. And again, we'll come back to that later. But again, R value, resistance to conductive heat flow. So if you look at our product, low E insulation, or if you've ever heard of low E windows, what does that E stand for? That E is emissivity. Now, emissivity is the measure of an object's ability to emit infrared energy. There's a whole lot of words there. Basically, what it means is if you hold up like a sheet of paper and you heat it on the top, how much of that heat comes through the bottom? Now, in this industry, there are two different products. There's radiant barriers and there's reflective insulations. There is a difference between the two. Radiant barriers, if anybody has any history with those, they are super thin. It basically looks just like aluminum foil. Might be multiple layers of foil, might have a layer of craft paper in there, but it's just tiny millimeters thick. The only thing that does is reflect. It has no inherent R value as a product, and it can't add R value to a system. It just reflects. The difference between radiant barrier and reflective insulation, or reflective insulation, like radiant barrier, it's part of a radiant barrier. It has that foil or metallized mylar facing, but it also has some kind of core. So it not only reflects, but it adds a thermal break. And the thermal break just means it's preventing the flow of heat transfer inside and outside of a building. Our products do have an inherent R value, and they can add R value to a system. The difference between our product and many of our competitors as far as reflective insulations go, most of those other products are using metallized mylar, which if you're not familiar with that, think like the inside of a potato chip bag or a happy birthday balloon. Some of those products are, you could take like the eraser on the end of a pencil and erase that facing. They are normally much less expensive products. They use inferior raw materials. The core of most of those is what's referred to as bubble pack, bubble wrap. That sounds exactly what it sounds like when you get a package in the mail from Amazon. You open that up, and there's all those bubbles, and the first thing you want to do is just pop all of those bubbles, right? If you do that with a reflective insulation, you're actually destroying the integrity of the product. It can create all kinds of problems. Our products actually use 99% pure aluminum. The only thing that reflects more than aluminum is silver and gold, and I don't think anybody's making any building products with those anytime soon. And the core of our product is a closed cell polyethylene foam. So instead of one or two bubbles per square inch, we actually have hundreds or thousands of little bubbles per square inch. Again, with those others, with that bubble pack, if you pop those bubbles, you're destroying the product. With ours, you can't actually pop the bubbles. It actually allows for contraction and expansion. If you squeeze it, it just pushes all the air in those cells out. But if you let it go, then all of that air comes back in. So let's move into heat flow. Now, remember earlier when we were talking about R value, and I said that it was the resistance to conductive heat flow. This chart tells you why that little fact is important. If you look at this, here we have conduction in all three of these pictures is only responsible for 3 to 7% of heat gain or heat loss. So all of that fiberglass, foam board, blown in, spray foam, whatever type of typical mass insulation you're thinking about, the only thing that is doing is slowing down. It's not even stopping, it's just slowing down 3 to 7% of the heat that on a hot summer day is trying to come into your house. On a cold winter day is trying to get out of your house. Convection, on the one hand, you see heat loss through the walls. That's responsible for about 15 to 20%. In the ceiling and roof, that's responsible for about 45%. In the summer heat gain, nothing. So in the dead of summer, when it's 90 degrees outside, only 3 to 7% of that heat gain is from conduction. The rest, 93%, is due to radiant heat, to radiation. And every other mass insulation on the market just totally ignores radiant heat. It's just there to slow down that conduction. So we look here. Why is this important to us? This is the sun and the earth. The sun is about 93 million miles away from the earth. The speed of light is about 186,000 miles per second. Most people don't know the speed of heat is the same. So what that means is basically when the sun comes up in the morning, it takes about 8 minutes for the light and the heat of the sun to reach the earth. Now, the first product we're going to talk about today is our low-E Thermo-Sheath. This is an ICC approved standalone roofing underlayment. So normally where you would have felt paper or some type of synthetic underlayment, whatever you would traditionally use, our product would go in its place. So right over the OSB goes our product, and right over that goes your shingles, your metal roofing, clay tiles, whatever it might be. This takes the place of whatever you would typically use. So we look here at a house without our product on it. So it's a hot 90-degree day outside. If you go upstairs in your attic, it's blazing hot up there. Nobody even wants to go up into an attic because it's 135, 140 degrees up there. People want to know, if it's 90 degrees outside, why is it 135 in my attic? That is because all of that heat, all of that radiant energy that is coming down from the sun is just cooking your shingles all day long. Your shingles on that hot summer day can get up to about 170 degrees. You can fry an egg up there. When we come back to that term emissivity, all building products have an emissivity. The emissivity of our product is 0.03. That means only 3% makes it through our product. We reflect 97%. We reflect the rest. With your shingles, the emissivity of a shingle is about 98%. That means 98% of that heat is going to go right through that shingle. The next thing it's going to traditionally see is that felt paper or synthetic, whatever, again, that you would normally have there. The emissivity of that is somewhere probably around 93 to 95. So 93 to 95% of that is going right through. The next thing it sees is your OSB. The OSB of wood, about 96%. So all of that heat that is being stored up in those shingles, that 170 degrees is working its way inside. Once it gets back into your attic, now it's in the air again. It's radiant heat, looking for the next object to touch. That's why it's 135 degrees up there. You've got your temperature, your thermostat set at 68, 70, 72, wherever you might typically put it. We obviously use about 70 degrees there as an average. So you're trying to, all of that heat that's coming in your house, you are trying to cool down to 70 degrees. I'm sure everybody knows over the past few years and moving into the future, electric bills have skyrocketed and will continue to. I don't think that they're going to come back down anytime soon. They tend to just go up. So that is why we are spending so much money, because it's so hot outside and we're trying to cool that down to 70 degrees. So the best way to relate to our Thermo-Sheath is coffee. Why is that? Because believe it or not, when you brew a hot pot of coffee in the morning, it's about 170 degrees, just like those shingles. Now, if you pour that coffee into this paper cup, it just burns your hand. You have to set it down right away, right? But if you pour it into a styrofoam cup, it's cool. You can carry that around all day long. Why is that? That's because that 16th or 8th inch of foam is providing a thermal break. It's keeping that hot 170 degree coffee from seeing your cold 98.5 degree hand. That's exactly what our Thermo-Sheath is doing on your roof. So let's look at what that looks like. Now you take our house with our Thermo-Sheath on it. Same 90 degree day. coming down, baking those shingles. They're 170 degrees. But now when it comes through, the next thing it sees is our product. So what we're doing is providing that thermal break. Now it's only 135 degrees in that attic. If you're using a metal roof, uh, stone coated steel, clay tiles, something that has an airspace inherent to its application, the sun is going to come down, it's going to cook up those clay tiles, that metal roof, whatever, it's going to pass through that. There's going to be an airspace, and then there's our product. So we're reflecting 97% of that radiant heat right back out. Now inside is only dealing with the 3% that makes it through. So that's why we can see up to a 30-degree temperature differential below the roof deck. When we come to shingles, obviously there's going to be direct contact there. So there is no reflectivity going on. When there's direct contact on both sides of our product, obviously we need an airspace to reflect. So if there's no airspace, there's no reflection going on. We have a third-party verified test that shows that even without that airspace, our product is still dropping the temperature about 8 to 15 degrees. But even that test doesn't really necessarily tell the truth because it's done in a box. There's no air movement or anything in there. In the real world outside, obviously there's wind, all kinds of different variables that affect this. What we've seen in the field is even without the airspace, our product is going to drop the temperature below the roof deck about 20 degrees plus. So not as great as that 30 degrees plus, but obviously you can still see a difference. At the end of the day, what we're trying to do is drop the temperature about 10 degrees once it gets into your house. So inside your house, where it says 70 degrees there, if it would normally, without our product, be about 90 degrees, then you've got to pay to drop that temperature from 90 to 70. With our product in there, dropping that to about 80, now you only have to pay to drop that 80 degrees to the 70 degrees. Obviously, that's where the energy saving comes in. That's where the money savings comes in. Why that's happening is up there in that attic. Again, 135 degrees up there or 105 degrees up there. Typically, whatever it's going to see next is fiberglass. In an unfinished attic, you go up there and you're standing on the studs and you're looking at the fiberglass in between each cavity. What that fiberglass is doing is is just slowing down the conduction. It's just holding that energy. It's basically acting as a battery. But all day long, that 135 degrees just beating on it, it's holding it up, saving it. If you notice, when it's starting to cool down outside, when it's 7, 8 o'clock at night and the sun is starting to go down and starting to get a little bit cooler outside, if you pay attention, your air is actually cycling more. And that's because A, it's still hot outside, but B, all of that heat that's been stored up in that fiberglass all day long is now being released into your house. That's why it's so hot in the house, and that's what you have to pay to cool down. Again, you put our product up there, and it's keeping that temperature in the attic so much. So it basically helps the fiberglass do its job better. We don't have products that we go into someone's house and say, we have the magic pill. All you have to do is use our product, forget about everybody else's. No, that's just not true. Use a little bit of their products and a little bit of our products. Working together is how you get the most efficient system. Now, looking at this in action, here is a picture of a house in Virginia. So there was a contractor using one of our products for a retrofit application. This was not using our Thermo-Sheath on the roof, but it was using a product very similar to our Thermo-Sheath on the underside of the roof. This product actually goes in each cavity, just like the fiberglass. It's made 16 or 24 inch on center. This contractor didn't necessarily think that he believed our product works the way we said it would. And he knew that there was a little bit of a snowstorm coming overnight. So what he decided to do was leave one of those cavities open. I'll let you guess which one that is. So basically what you can see there is that's how much heat you lose through your roof just overnight, enough to melt the snow. If there was no Thermo-Sheath, if there was none of our product there at all of that snow would be melting off the roof. Now that could be dangerous for a number of reasons. Number one, when it melts, it's rolling down the roof. That can lead to some ice damming. That's how you can get some water infiltration, water damage to the roof, and also start forming really long and dangerous icicles as well. But the point is, that is how much energy that you're losing. So you're paying, everybody yells about, hey, keep the door closed. We're not paying to heat the outside, or we're not paying to cool it down. We still kind of are. Despite all of our best efforts, all of that energy is still escaping the house somehow. Another cool thing about our product, the Thermo-Sheath roofing underlayment, is it actually self-seals around fasteners. Yeah, so it actually forms a gasket around every fastener. There are thousands upon thousands of penetrations on a roof. Obviously, you think about how many nails you have to put down just to secure the underlayment, and then every shingle or whatever has at least 3 to even 4 or 5 nails. There's just thousands. Um, and Contraction and expansion obviously is what leads to those nail pops inside. There's nothing that can be done about that. But those nail pops become an issue because down the road, if water can get in there somehow, the water travels the path of least resistance, finds those little nail pops, makes its way in, and starts causing roof damage. It can be 2, 3, 5 years down the line. You don't even know that there's roof damage until all of a sudden it starts falling apart. So our product, again, actually self-seals around those fasteners. So why that's important to most contractors is if they have to go back to Mr. Johnson's house to fix a roof leak, they're not making any money. They're back there working to fix an issue. So they're not over at Mr. Smith's house making money on a new roof. Now, the next product we're going to talk about is our low E house wrap. Again, low E house wrap, ICC approved, standalone house wrap. So instead of the felt paper or synthetic on your roof, this actually takes the place of Tyvek, Typar, whatever, again, house wrap you would traditionally use. Behind hollow back vinyl siding, our house wrap adds an R4 to the wall system. The easiest way to relate our house wrap to people is talking about low E windows. Here we go back to the low E windows. Everybody knows that they need to have low E windows, right? But does anybody really know why? No, they just know that that's what they have. They're energy efficient. They save me money. But why are they energy efficient? Why are they saving you money? 2 reasons. Number one, a low E coating. There's that word again, low E. So when these windows are being manufactured, when they're curing, when they're still in a molten state, they're all along the conveyor, they're actually sputter coated with 7 different kinds of metals, one of which is aluminum. The reason that is, once that window cures, becomes solid, it's reflecting radiant heat. The second is argon gas. So you have two panes in these windows. What they do is they take a little needle and they punch a hole between those 2 panes and they inject argon gas. They do that because argon is a little bit more dense than oxygen, so it takes a little bit longer for the heat to transfer through. All of that is, again, just for energy efficiency. But if you think about it, your windows only make up about 15% or so of a house. So the other 85% is just open. There's not the energy efficiency there. If you're going to low E your windows, why would you not low E your walls? So then we look at this next picture, and what this is a picture of is thermal bridging. So this is a house right here around the corner from our office, actually, about 5 minutes from here. On a cold winter, fall-ish morning, it's cold outside. The sun is coming up. You can see, again, that you can see the stud package of that wall. That is how much heat that you're losing through your studs. So you think about it, there you have 16-inch on center build. So each one of those 16-inch cavity has fiberglass or, blown in or spray foam, whatever it is in there. So that's where the efficiency comes from for that. But you think about those studs, again, if we go back to the emissivity, 96% of the heat is just transferring right through those studs. That's why you can see them on the outside. They're warming up to the point that you can see the whole package. If you would take all of those boards and slam them to one end of the wall, that's making up about 25% of your wall system. So again, here, we're insulating only 75% of the wall system, really. The other 25%, we just don't worry about. If we take our house wrap and we put it over that, that eliminates the problem of the thermal bridging. Both of these products install just like any traditional roofing underlayment or house wrap would install. They have foil flanges on the end of the roll that actually serves as the overlap. So the other cool thing about our product is with a typical felt paper, synthetic, Tyvek, Typar, you lose about 10% of the product in your overlaps. With ours, it's built right in. So the foam core of these products, one of them is a 1/4 inch, one of them is an 1/8 inch. Once I get out of the presentation, I'll show you a piece of both of these products so you can get an idea of what they look like. Um, but if you can see this, so the first run of Thermo-Sheath has this foil flange on it. You would point that towards the roof, cut it off, fold it under, whatever, so that it's not out there flapping in the wind. But then with every subsequent run, what happens is you just butt the foam core of the product, and then the flange lays down over it. So with each one of our rolls, they're 4x125. It's 5 square per roll. You're getting a full 5 square coverage out of that. You're not actually losing anything in the overlaps. The other thing about both of these products is they both serve as sound deadeners. The 1/8 inch roofing underlayment is equal to about 1.5 inches of fiberglass. The 3/16 of an inch house wrap is equal to about 3 inches of fiberglass. We use a product very similar to the roofing underlayment as a flooring underlayment, and that has better sound attenuation than the high-end sound deadeners that are just flooring underlayments on the market. So especially in 55 plus communities that are starting to pop up all over the place, like wildfire. The older you get, the more quiet you like it. I'm not quite 55 plus, but I already want it quiet in my house. So we help with that. We help keep out when it rains outside. The rain's not as loud. If you live in any areas where there's hail, especially anything like that, at the end of the day, basically, we're just helping to keep it quieter in the house as well. The other cool thing about both of these products is they qualify for tax credits. The Inflation Reduction Act, we used to qualify for some federal tax credits, and they ran out at the end of every year. So I think it started back in maybe 2015, and then they expired. And then in 16, it took them until something like June or July to say that, yes, they were going to re-up the tax credits. So for 2016, somewhere around 2019 or 2020, around COVID, those tax credits disappeared. But on the other side of that, they came back as a part of the Inflation Reduction Act. The great thing about this is in effect until 2032. So this doesn't expire at the end of the year, doesn't expire at the end of next year. This runs for another 7 years. So this is going to be a 30% rebate on material only, up to $1,200. So for our roofing underlayment, for the house wrap, both of those products, normally we say there's an ROI of about 3 to 5 years, which again, there's no other insulation on the market that's going to give you that kind of ROI. But now with this tax credit involved, that can actually drop that time pretty dramatically, depending on where you live across the country. It could only be as little as 1 to 3 years before our products pay for themselves. There's a booming solar industry right now all over the place. People are trying to upgrade to solar. The solar on your roof is going to be, $50, $70, $80,000. That is quite an expensive upgrade to a house. Our products don't cost nearly that much, obviously. Again, so they're probably going to add, again, depending on where you're at and with that tax credit involved, maybe $800 to $1,500. So that's how we're offering that ROI. We're dropping your temperatures to the point where we're going to pay for ourselves. And like I said, 3 to 5 years with these tax credits, maybe 1 to 3 years. Now we get into building codes. So to understand how we help you meet these building codes, we need to talk about the difference between R value and U factor. They're both related to thermal performance, but they measure different aspects of heat flow. So the R value, it quantifies the heat resistance of an individual insulation product, like a fiberglass that we talked about before. The higher values indicating a better performance. So of course, R30 is greater than or more efficient than R19. When we're talking about U factor, that measures the heat transfer through the entire building assembly like a wall. That considers all the materials involved. So that takes into account the air spaces, the fiberglass in the cavity, the OSB, all of your studs, your house wrap, everything that's in that wall cavity. With U factors, It's the reverse of the R value. Lower value actually indicates a better performance. So over here, the 0.045 is actually greater than or more efficient than the 0.051. Now, how this relates to the building codes is using our house wrap. So here we have a climate zone map. So there are climates, there's 8 climate zones. As you can see here, the 8th is very small. There's just a little part up if there in the Northwest, I think. Every one of those climate zones has its own building code, and that goes for walls, rafters, absolutely every aspect of a building has some kind of code to it, obviously. The 2021 codes, as you can see here, for zones 4 through 8, that U factor requirement is a 0.045, or there's 4 ways to meet it when R value is concerned. Either an R30 in the wall, it doesn't matter how you get it, or a 20 on the interior and a 5 continuous on the exterior, or a 13 in the wall and a 10 continuous on the exterior, or my favorite of all, 20 continuous on the exterior, nothing on the interior. Now, a few years ago when the R values changed to R20 and 25, people had to stop building. Most people switched from a 2x4 lumber package to a 2x6 lumber package. Now with an R30, or once it starts to go a little bit higher than that, which again, 24, 27, 30, it's bound to go higher than that, I'm sure. We may see lumber packages start going to 2x8s, 2x10s, which obviously all of that means more money, more cost. Even if you tried to go the R20 with the 5 continuous exterior, that means the easiest way, probably an inch of foam board on the exterior. But now, so you're paying for the labor of putting up your house wrap, you're paying for the labor of putting on that foam board, and you have to pay for the labor and pay for the parts of window and door jamb extensions. 13 and 10, obviously the same. The 20 continuous, obviously the same. All of this just gets more and more and more and more expensive. Or if you look down at the bottom, the easiest way to hit this. The least expensive, I think, depending on where people are getting products. Again, you have to think you're staying on a 2x6 lumber package. You're taking out the cost of your house wrap, your Tyvek, whatever. You don't need any window and door jamb extensions, anything like that. You just use our house wrap on the exterior. With an R21 in the cavity and our house wrap, that's actually a 0.043. So that not only meets the new code, it actually exceeds it. Again, U factor lower, better. So the 0.043 is better than the 0.045. So again, this could possibly be the cheapest and the most energy efficient system. But even for zones 2, 3, wherever else you may live, our products can help. Again, back when it went to an R20 and people were switching from 2x4 to a 2x6, they could actually use a high density R15 in the cavity and our house wrap on the exterior and still meet that code and stay on a 2x4 instead of switching to a 2x6. So there's different ways for our products to help meet this sidewall code all over the country. One of the other products that we have here, our third biggest product, is our slab shield. This goes under concrete. It is a full vapor barrier and radon barrier. So if you live in a state that requires radon barriers, obviously this should perk your ears up a little bit. This goes right over, your stone, and then you can put in, again, right on top of it. You can stick your rebar right through it, and again, self seals right around all of that. It is great for, there's a radon application. You got to tape up all those pipes. It's great for snow melt systems. So this is someone's driveway out in the Pacific Northwest. So as you can see there, all that PEX tubing, you run, you come up, it snows overnight. You wake up in the morning, all you got to do is flip a switch, run hot water through it, and no shoveling. So our product, again, is just going to keep from losing that heat into the ground. And again, also full vapor barrier and radon barrier. But we have, like I said at the top, about 35 to 40 products. It's used in single family homes, multi-family homes, new construction, remodel, DIY. You can see all of these different applications. At the end of the day, basically what we're telling you is if you have an application where you're worried about heat loss or heat gain, we have a product for you. You'd like take a look there at that first picture up in the corner. There's our flooring underlayment that I was talking about. The one next to that, that's actually a cathedral ceiling application. Moving over one from there is in a crawl space. Over to the next corner, that is our tab. That can be used, like I said, that's manufactured in 16 and 24 inch and goes in each individual cavity, just like the fiberglass. That can be used in walls, rafters, crawl spaces, all these different applications. Then the next one down in the opposite corner again, we have HVAC duct wrap and an attic floor insulation. We have garage door insulation. We can wrap pipes. We can wrap hot water tanks. Like I said, if you're worried about heat loss or heat gain, chances are we've got a product for you. We tell people never to throw away scraps of our product. There's hunters cut it up and put it in their boots. They cut it up and put it in their sleeping bags. We have someone that makes their own cheese here close to us. They have their big cauldron lined with our products. It's crazy, some of the applications that we get into. But it's not only residential, it's also commercial, metal and post frame buildings. If you take a look here at that first picture in the upper left-hand corner, at least it's the upper left-hand on mine, not sure if it's backwards for you guys, we have a white face product. With most of our competitors, their white face is actually a vinyl or some kind of poly. The point is that breaks down over time. Some of those products have started using UV inhibitors in there. It's still breaking down over time. We've gotten calls from people in these bigger commercial buildings, and they'll say, it's snowing in my building, or my building has dandruff. It's that white face is actually starting to crumble and fall apart and just starts falling down to the floor. Our product is still 99% pure aluminum face. It just has a white coating on there, baked on sort of the same way that they bake on colors to metal roofing panels, things like that. But again, we've got products that are used in the walls, used in the rafters, used all over the place. To summarize here, again, our product works whether in the summer or the winter. What we often say is that we will keep your house warmer in the winter or cooler in the summer. If you remember back when we talked about convection and heat rising, and I said, yes, that's true, but it's not the whole story. One of the first laws of thermodynamics is hot goes to cold. So it doesn't matter where it's cold. Yes, it rises, but it also goes down, in, out, left, right, sideways, diagonal, and every which way it can. Heat looks to displace cold wherever it is. So when it's hot outside, we are reflecting that radiant heat back out. We're keeping that heat from coming inside. When it's cold outside, we're reflecting that heat back into your house. We're keeping it from escaping. So the key takeaway points here for our roofing underlayment and our house wrap, especially, those are our two biggest products. That additional R value, the self-sealing core, sound deadening for both products. Obviously, at the end of the day, what we're looking for is to save money. We're lowering the energy bills. We're saving you money, which is only helped by the fact of those tax credits right now. Both of these products, ICC approved, stand alone. They add a thermal break and they prevent that thermal bridging, and they're giving you that true 5 square coverage. Now, with all of these products, again, I was trying to say there, we have testing for everything. We are the kind of company that does not say something unless I have a test that I can show you to back it up. Needless to say, not every company on the market is like that. So the only thing I would tell you is if you're dealing with any of those radiant barriers or any other reflective insulations on the market, all decent enough products, they have their use. But as far as a roofing underlayment and a house wrap, we believe we are the only ICC approved reflective underlayment and house wrap. Our competitors cannot make the same products that we do, again, because they're using that bubble wrap. So that can't be, they can't use that as a house wrap. They can't perforate that like our house wrap, because once you put holes in it, you're destroying the product. The water gets in there. And both of these products are patented as well. So that's the end of slideshow. Let's get out of there and stop sharing. Um, Kayla, how do I get rid of this poll? I can't. There we go.
You can just exit out of it. There we go. Awesome. Well, thank you for that. That was really helpful. I think we can go ahead and jump in some questions now. We'll start off here. We've got a couple people asking for the PowerPoint presentation. Would you be willing to share those slides afterwards?
Absolutely. And if you go to our YouTube page, so if you go to YouTube and search for low-E insulation and click on our page, it has the little circle. You can see a number of roles of our product. That's how there's a number of things that pop up there. But if you look for the picture of rolls of insulation, that's our page. There's actually the PowerPoint is on there with a voiceover laid onto it. So it's basically everything that I just said in that PowerPoint. It's about 20 minutes long. And then there's also a bunch of other videos there as well. But yes, absolutely, I can share the PowerPoint with anybody.
That's good to know. Awesome. All right. Next, we have someone asking, can you address the concerns on creating an overly tight envelope?
Um, that I believe, without being able to interact with the person asking the question, that's a question asked a lot of spray foam, because that certainly makes it tight. Some would say airtight. Our products are not necessarily full air barriers. They will obviously block some wind. That is the point of especially the house wrap and the roofing underlayment, is to block some, but they don't create. It's not wrapped so tight that it's a complete air barrier that it's impermeable.
Mm, got it. All right, next, we have, do you have a vapor open house wrap for northern climates?
So like I said back there, I would show you a couple of samples. Not sure if these are big enough there, but this is our roofing underlayment. It's an 1/8 inch thick. It's double sided. Here's that foil flange that I was talking about. If you look at our house wrap, the difference is it's a little thicker. It's also single sided. There's only one side of foil. And I'm sure on there you can't tell, but if I shined a flashlight through here, this is actually perforated. So the way that most house wraps are tested to meet the ICC standards to be a house wrap, to be a standalone house wrap, is they put together like a 4 or 8 foot cross section of a wall. They put the house wrap on front. They put some kind of apparatus on the top that just drops water the whole time, and they put high powered fans out there that just blowing that water back through. Then they put their sensors on the back of it to see how much water comes through. So again, you probably can't see it, but the perforations on here, it's a patented process. They are placed to 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 meet to beat these tests. It actually performs better than Tyvek when it comes to water infiltration. What the perfs do is, when there's water on the exterior, again, it's a closed cell polyethylene foam. It's oil based, so it's hydrophobic to begin with. Water may kind of start to pool up on the face of one of those perfs, but it can't come through. Eventually, the weight of it just drops it right out. If there's any vapor on the interior, or if there's any water on the interior of the wall system, which obviously there always is, we're always trying to get that condensation out of the house. Once it turns to vapor, the condensation that can escape through these holes. So water can't come back this way, but the condensation, the vapor, can escape this way.
Amazing. Yeah, great. Thank you. Next up, we have, can this product go under metal roofing or EPDM?
Yes, it can go under basically anything. With the EPDM, it is a little bit more challenging with steep slope roofs. Anything below 412, you need to use 2 underlayments, but that goes with any underlayment that's not just ours. It can be used in just about any application. Just depends on what that application is and how work intensive, and some other workarounds for it. If there's any questions about that, always, you can always ask us about a certain project that's coming up.
Yeah, that's great. All right, next we have, is this material fire rated?
The house wrap and the roofing underlayment are not necessarily fire rated because they don't necessarily have to be. Um, what I can tell you is our very first product, again, going all the way back to the beginning, there was one product that was low E insulation, most similar to the roofing underlayment, but it's a little bit thicker. That is a Class A, Class 1 fire rated product. It passes the NFPA 286, the full room burn test. Um, so it's chances are they would perform very well. We just haven't had either of those tested for fire ratings because they don't need them. But any of the interior products that need to be tested, yes, we certainly have copies of all those tests. And that goes for the, like I was saying, as far as having testing to back everything up, when it comes to the emissivity of the product, the R values, the permeability, all of that stuff, have all the testing you want and more.
Perfect. Okay, and now we have, what's the perm rating for the house wrap product?
For the house wrap, I believe is 7 perms.
Perfect. And next I have, can you explain your warranty and what it covers?
Sure. We have a 30-year warranty. The reason that it's 30 years is because we've been in business for 35 years. This product, chances are, it was a 20-year warranty. Now it's a 30-year warranty. Chances are 5 years from now, it's going to be a 40-year warranty. To give you an example, we have pipes on the exterior of the building that are wrapped in this product. They have been wrapped since before I started here, which was 21 years ago, and they are still fully intact. Chances are this product is going to last as long as the building does, if not longer. So the warranty is 30 days, covers obviously, manufacturing defects, all of that. And we have copies of all our warranties and all of that as well,
Perfect.
and can be found on the website. Sorry.
Okay, good. That's great. All right, I think that's our last question right now. Oh, actually, one more just came in. Can you speak to the sustainability of your products?
So yeah, actually, good question. The the polyethylene that's used to make the foam core, some of that does come from recycled products. As much as 20%. It's certainly not always 20%. The Thermo-Sheath, if you ever get a look at these products, you can see that the foam of the house wrap is actually white. You probably can't see that little tiny bit in there on the Thermo-Sheath. It's actually gray. The 1/8-inch product, there's more recycled content. But yes, as far as the sustainability, we can help qualify for LEED credits. Obviously, we are an energy efficient product, so sustainability is what we are all about.
Awesome. Well, I think that wraps it up then for questions. Jeb, did you want to make any final comments or notes before we hop off?
Just like I said, if there's any questions really about anything, but certainly any of the testing or any of that stuff, there's a lot of it that can be found on the Acelab site. There's certainly more of it that can be found on our website. And any kind of questions, that's what we're here for. Our 800 number is there. Brochures, samples for the testing, for any of that stuff. We do have spec sheets for the house wrap product, for the roofing underlayment product, and for that slab shield, the under concrete product. If anybody needs help with any of that, those will be available on your site as well once we get all of that added. But no, really, just if anybody has any questions, it's a product that, like I said, it's pretty boring. Unfortunately, I've worked here 21 years. I still get excited talking about it, but I still can't get that excited about it. It's reflective insulation. You can get in the woods pretty quickly with it, and especially with meeting those new codes wherever you might be at in the country. At the end of the day, it's just if anybody has any questions, that's what I'm here for.
Yes. Yeah. Thank you so much, Jeb. And thank you everyone for joining today. We hope you all have a great day.
Thanks, Kayla. Everyone have a good one. Thank you.